Well, we're back in the weather lab with a stormy weekend on the way. So let me break down what is causing all of this little mayhem, I guess you could say, with showers and thunderstorms. And also, I just want to touch on the tropics real fast as we have an update on that as well. So first of all, we have our cold front that is on the way, slowly pushing in. Look at the temperatures behind this cold front in the 60s. Notice the dew points are in the 50s. Ahead of this cold front, we are in the 70s and 80s, pushing in some locations up to the upper 80s, with our dew points in the 70s. So we have a tropical air mass ahead of the cold front, a true polar air mass behind the cold front. This is really the first true strong cold front with a true polar air mass that we've seen as we start fall. So it's perfect timing. But this cold front has been and will continue to pack quite a punch with showers and thunderstorms, but it's going to move slowly. So let's look at some of the reasons why. First of all, when we take a look at our showers and thunderstorms on the WeatherTap radar with the surface map, notice our cold front has gone stationary here with another wave of low pressure set to lift to the northeast, dragging this cold front through. While that is happening, showers and thunderstorms keep on reigniting. We had our first wave move through some areas, already producing heavy downpours, some areas with severe thunderstorms due to the downburst wind gusts pushing over 55 miles per hour, and some hail. And you can see this wave just marching its way towards the coast. It will lose a little bit of punch because of the reduction of instability, which I'll show you in just a moment, along the immediate coast, especially around Long Island. But still, we have additional waves right here around Baltimore getting ready to lift to the northeast. And then we have another area of moderate to heavy rainfall that is currently in West Virginia that is set to move towards our region. So what is going on here? Well, let's take a look first at the skew T. Notice all the winds are from the same direction. So this is all unidirectional. So this means that we don't have much in the way of directional wind shear or what would typically create tornadoes, but we have some speed shear setting up here, especially between 800 millibars and 400 millibars here, that is supporting the potential for some downburst wind gusts. Also notice we have a lot of deep moisture here that is getting lifted with our instability pushing as high as 2,200 joules per kilogram, a little bit higher than what was expected in the model guidance. But we also have a lot of moisture, right? 1.8 inches, which was expected. So you have that instability lifting up, and it's that deep tropical moisture is lifting into this dry pocket right here. So when it does, it condenses, which is what you see right here. And when it condenses, it cools and slams towards the ground. So that's what causes our downburst wind gusts. We can see this live with our skew T right here. Perfect Cape signature right here. Setup is pretty good for those strong to severe thunderstorms. Now let's break this down further. So first of all, here is our precipitable water values that you can see here on the spc.noaa.gov free website. You can see the focus here, the gradient set up right over the I-95 corridor. So this is going to help to ignite those thunderstorms capable of heavy downpours and also support the moderate to heavy rainfall that will be on the way for tonight into tomorrow morning. So this tropical moisture is slowly getting pushed out by this polar air. But why slowly? Why isn't this just slamming right on through? Well, we'll talk about that in just a second. I want to also show you the instability here that is supporting these thunderstorms. Our lifted index, our lower lifter index is ranging anywhere from roughly 6.5 to almost 8.5 here in the Delmarva Peninsula. That's pretty impressive. But let's take a look at the Cape values here, surface-based Cape. And you can see there is that 2,500 joules per kilogram right on the I-95 corridor, a little bit of urban heat island influence right there. Notice here on Long Island and right along the Jersey Shore, as these thunderstorms approach, they are going to run into a slightly more stable environment because of the Atlantic Ocean. But that means these thunderstorms get elevated, and that will support very heavy downpours even on Long Island. So I would not let your guard down. Yes, the thunderstorms will weaken as they move into this environment, but they'll be capable of that very heavy rainfall. Finally, I want to show you, this is all via speed shear here. So that's why we're seeing this bulk shear set up, and that's why we're seeing the potential for some of those thunderstorms reaching severe levels. This is not tornadic, though. The reason why we can say it's not tornadic for the northern mid-Atlantic is because we have more directional shear. Now, what I'm wouldn't be surprised to see is some tornado warnings due to the downburst nature of this wind structure that will create on the radar a turning signature, but in reality we won't actually get a tornado actually observed, but we'll get a tornado warning because they're going to pick up that signature on the radar and they don't want to miss a tornado that actually it's the ground. It's better to warn and nothing actually happens than to not warn and then people are unprepared. So that's why we do what we do. Now, why is this cold front moving so slowly? Look at the nature of the upper level winds. They're running parallel to the surface cold front. So when that happens, the cold front moves very slowly. Think of it this way. If you're moving furniture, you want to move it, ahead, right? You want to pick it up and lift it, right? So if you're trying to move something and you're moving with the direction of the gradient, you're not going to move it very quickly. But if you're moving it against the gradient, then you're going to push it much faster. So in this case, this cold front is slowly moving because the upper level winds are aligned such that right with the cold front. Once this trough gets here, then that cold front gets kicked out, which is what's going to happen by tomorrow afternoon. Again, you can see out here, this is 850 millibars with the temperatures. Here's our true polar air mass back here, really chilly back here over the the central Great Lakes and northern Great Lakes. That's below zero, right, at 850 millibars. This is a true polar air mass, and then here's our tropical air mass. Again, the cold front is aligned with the southwesterly winds, so the cold front moves slowly. Once these winds shift more to the west, like what we're seeing here in the Ohio River Valley, then this cold front will exit. So when is that going to happen? Well, let's take a look at some of the model guidance here. See if I picked the right one. Here we are. Okay, so this is the HRR guidance, and you can see it's slowly coming in. So it still has some guidance that has to come in, but you get the idea here. Showers and thunderstorms continue to lift through the region, and then you can see that rainfall setting up as the cold front is slowly moving through. When we take a look at the NAM, which is completely updated, same scenario here, and then here comes our rainfall coming in over the overnight hours into tomorrow morning. So if we're heading out let's see, I think the Jets play at home, they will be dealing with some rainfall at the tailgate, but I think at the start of the game you'll start to clear out. Variable cloud cover, but the bulk of the rainfall will be over. So the Jets game should be fine. But even for the Giants game down in Washington, again, the pre-game, a little damp, so if you have plans for that, you might want to prepare for that, but it should be fine for the actual game itself. But we are setting up for a rather wet evening and overnight hours. Finally, I just want to touch on the tropics. As you know, everyone was freaking out about the potential for a major storm, and people were putting out crazy maps. I warned you, don't jump the gun. Well, people jumped the gun, and guess what? Now we don't have a real disturbance hanging around the region. In fact, what we have in place here is something that is less than 20% chance of developing. And the way it looks like right now, it doesn't look like it's going to develop at all. And when you take a look at the actual observations, you got a circulation here, but it's not very well defined. It's very weak. This isn't going to develop because we have an unfavorable environment. And this is why, ladies and gentlemen, you do not trust model guidance until you get a sustained warm core circulation with sustained convection. Once you get that point, then you can start making your maps. Until then, it's all fancy land, meant to get clicks from you. But I'm not about that. You know that. So we'll keep an eye on these showers and thunderstorms as they continue to evolve. I think we're going to shift more towards a heavy rain threat than a severe threat as the atmosphere becomes more stable. And then by tomorrow afternoon, the polar air starts to come in and it starts to get very refreshing and very nice for the rest of the weekend. So in the meantime, stay safe out there.